Welcome to Dashboard of Data Analytics of Asset Tracking and Monitoring System. This dashboard is made by using Django and Dash frameworks using multiple visualization libraries such as Folium, Leaflet.javascript and Plotly Express. We are signing into the dashboard as super user. Total count of devices being tracked is displayed at the top of this home page. As you can see, we are currently tracking 4,067 aircrafts, 6 cars and 14 trucks. This map shows live location of our tracked objects. This button is used to update live locations on our map. Density heat map shows aircrafts with respect to their altitude. Color scale indicates that green color represents aircrafts that are flying high above 100,000 feet in a region such as Australia. Now, there is an insight page to view monitor vehicles activities. This page is currently displaying insights of a car. To view truck insights, we can click this button. Moreover, we can choose different vehicles from this drop-down. This map demonstrates most taken routes of car V3-15, observed by the system. If we zoom in, we see that pink color shows that this car mostly takes this route from 837 Wellington route to Victoria Hospital. After pink route it mostly runs on purple route, then after purple it usually goes on this turquoise route. It provides facility to observe vehicles' behavior during past days. This bar graph is representing estimated activation period of car, which means that vehicle V3-15 is most likely to be active at 7 p.m. to 8 p.m. on Tuesday. This gauge indicates that vehicle V3-15 is mostly found in running state at night on 7 p.m. Estimated activation count demonstrates predicted movement of vehicle on each weekday. Let's check this. It is predicted here that car V3-15 would be running 0.38 hours on Sunday. Vehicles' overall activity can be observed in busy period chart. This chart represents that car V3-15 is mostly found active during 7 p.m. to 8 p.m. and least active from 9 a.m. to 10 a.m. Do you ever wonder where your driver is actually taking your truck to? What are the most visited locations by your car? This activity can be seen in this chart. This color scale represents most to least visited locations by a car. We can hover on individual point on the map, and we can see at what place my car is usually present. This table shows that the car has visited 837 Wellington Road, Lockwood Park 47 times, and specifically 827 and 835 streets 17 and 19 times within this region. Daily activation count shows that how many hours in past days my vehicles was found in moving state. Let's check for the month of June. We can see that it had run 0.44 hours on the 12th of June, and about 0.59 hours on the 13th of June. Your vehicle's consumed fuel can also be monitored. This bar chart shows that your vehicle had used 4 liters fuel on the 22nd of June. Peak speed indicates highest speed of the vehicle. Here it shows that highest speed of V3-15 is 72 km per hour. It is a useful insight to track over speeding of your vehicles. We can also predict that how many liters of fuel is required by a vehicle on a particular day depending on the historical behavior of vehicle. Here we can see that V3-15 requires at least 1.289 liters of fuel on Saturday. This solution does not only provide with tracking, but it also facilitates its users to check past history of the tracked objects. Now let's see the past activity of V3-15. We can choose date from this date ranger. Let's see its activity from 1st September till today. Now, we are able to monitor that our car V3-15 was moving from this starting point to this ending point during these days. This table represents data of selected range in tabular form. Last is collision detection. We can see whether 2 or more aircrafts depending on their current state can collide or not. Let's check it for aircraft 7, 6, 6, 8, 2, 5, 3. There are 3 regions in this map. Aircrafts that lie in first region have higher chances of collision. Aircrafts in second circle have comparatively low chances, and aircrafts that are outside all these regions are considered safe. But it is not over yet. There are other parameters as well that are used to predict collision detection, such as vertical separation and angles of both aircrafts. If we hover on the selected aircraft, it shows lines pointing to the aircrafts that may collide. This pie chart shows chances of aircraft's collision. Aircraft 7779568 has 14.4% more chances of collision than other aircrafts. If we hover on one of the danger state aircrafts, it shows us percentage of chances of collision along with the estimated time of collision in hours. One aircraft lies within the region, but still it is considered as safe. Its reason is that if we check tabular data, we come to know that it is flying 13,550 feet above the monitored aircraft. Aircrafts that have vertical separation below 2,700 feet are considered danger, else they are safe. The core idea behind this project is a PRS technology, which uses radio signals for data transmission. All vehicles and assets that needs to be monitored are connected to our system by using the PRS devices, which sends data to Google's API aprs.fi. Data analytics of asset tracking and monitoring system is a powerful dashboard that pulls data from a aprs.fi API, processes it to provide usable insights and powerful tracking services. Thank you very much.